Okay, so in the video, we're taking on a tour of local environment to have a look at different wildlife populations, which is essential for understanding and protecting ecosystems. Our task is to create a counter that could be used to count wildlife, trees, mini beasts, or anything else relating to life on land using a microbit. So this is an activity from the microbit website. And it is a coding walkthrough for lots of different activities. But we've added a wee bit more to it. We've added in sort of an idea of a specification and the idea of designing and thinking through the steps of your code before going on to code it.
So Maggie is now going to lead us through the coding part of our session.
Okay, so before we code, it's important to understand the problem that we're trying to code, and also to make a plan or design the solution to inform how we can code it. Now, our unplugged part of the session took us through how we would manually keep track of two counts, one for player 1 and one for player 2 when playing rock, paper and scissors. We're now going to code a counter for a species 1 and a species 2. But we need to consider how a computer would keep track of these counts. If we think of the microbit and our von Neumann diagram as well, how can we give it input?
We can use those buttons. Show me the buttons, Amanda. Yeah, she knows.
Yeah, that's correct. Now, what we could do, if the pupil presses a button A, we could make that count for species 1. So if they see a mini beast of a certain species, they'll hit button A, and the same for button B for species 2. Does that make sense?
Yeah.
But what is it we want the computer to do when we press button A or button B?
So let me think. If it's like keeping track of the count of the species that the pupil are seeing, so if the pupil hits button A, it means that they've seen species 1, and therefore it should record 1.
Okay, so what do you mean by recording though?
So it's like adding on 1 to the count.
Yeah, it's adding on 1 to the count. That's what we want it to do. Okay, perfect. So when we press button A, we want the microbit to add 1 onto the species count, and the same when we press button B, we want a 1 added on to species 2 count. Now, in our discussion on the microbit, we discussed inputs and outputs, and when we looked at the device, we said that button A and button B were input devices. So we are using the input buttons in the microbit to record how many we're seeing of different species. Now, the spec on our board here also says we want to display the scores, okay? And in this spec, we want to see a species 1 score and then a species 2. Slightly more tricky, but we need the microbit to somehow display the counts. How could we do that? Remember from our intro to the microbit that we have an output device, the LEDs.
Well, we haven't combined using A and B buttons together yet. Could we do that?
Absolutely. So let's say for species 1, if we press A and B, then it will show us the species 1 count. What about species 2 count though? Is there another way to get the microbit to respond?
I know this one. I do know this one. We could shake it.
We could shake it. Great. So on a shake, we're going to show species 2 count. Okay, that all sounds good. And you can see from the Miro board, we now have a specification. And sometimes we call that the software specification. You'll hear people talking about a spec. This is it. This is what the program is wanted to do. And it's important to have a clear idea of what your problem is. And by doing unplugged activities or brainstorming with pupils, you can build a specification to clearly define and detail the problem. Okay, once we have the spec, we can now start to design a solution. And that solution is then what we will go on and code. Design's an important part of this process. And what we're trying to do is then take the leap from the spec towards coding the problem. And if you think of many real-life problems, they are designed before they are produced. If you think of architectural drawings before a building is built, if you think of the planning that goes into an event before it's arranged. And the same goes for writing a programme. So it's good to get pupils to think about the steps they have to take to make the specification work. Now, there are different approaches to design, and we have developed one that we will talk you through now. How does that sound?
That sounds good to me. I'd love to see this.
Okay, so we've developed a card, and you can see that in the bottom right-hand side of the Miro board at the moment. So initially, it may be that you choose to fill these out and give it to your pupils initially when they haven't maybe done any coding, and then take them to the coding part. And then it may be that as they get more experience, they start to fill these out themselves and get more understanding of it. Now, at the moment, there's a lot on that card, you know, and these are suitable for when it comes even to be quite complex problems. But we're not going to use all the lines of them for this problem because we've got quite a simple problem. But we're going to use them to design this.